So in this video, we're going to talk about some special cases in solving systems. So some special cases in solving systems of equations. So we're going to do what we've been doing. So for example, we're going to solve the following. So maybe problem 1, we're going to solve 2x minus y equals 2 and minus 4x plus 2y equals negative 4. And so if we go about and let's say we're going to use elimination, if we notice actually at this point that if I just multiplied this top equation by a positive 2, I would get a positive 4x here, and then that positive 4x would cancel with this negative 4x. So I'm actually going to kind of use that shortcut a little bit. So usually I say you have to multiply both equations by something, but sometimes the problems are nice enough that you can make something happen. So in this case, we end up with 4x minus 2y equals 4, and minus 4x plus 2y equals negative 4. And so if I add these two equations together, the 4x minus 4x, the minus 2y, and the plus 2y, these both go away. So I'm left with nothing on the left-hand side. So when that happens, that means I'm left with 0 on the left-hand side. And on the right-hand side, when I add 4 and negative 4 together, I also get 0. So I end up with 0 equals 0. So anytime that you're solving a system of equations and you get 0 equals 0, what that means is that there are infinitely many solutions. And that's one of the cases where, if you think back to that video I did where stuff was graphically, that was the case where the two lines end up being right on top of each other, right? So I found one line and then the second line ends up right on top of it. So on a test, writing infinitely many solutions would be all you would need to do. But in ALEKS, they sometimes then want you to take one of these equations and solve it for y, and that's the solution. So the solution has to satisfy one of the equations because you're looking for all of these dots that are on this line here, right? So you can think of this line as having lots of dots. So you're talking about all of those dots. So to find that, so if I started with, say, 2x minus y equals 2, and I solve this for y, I would subtract 2x from both sides. So I'd have minus y equals minus 2x plus 2. And then I would divide everything by negative 1. So y is going to end up being 2x minus 2. So there's infinitely many solutions, and the solutions satisfy y equals 2x minus 2 because they're all on that line. So let's try another example. So example B, I have the equation 3x plus 2y equals 5 and 4x minus 4y equals 4. Okay, so again, let's try and get rid of x, right? So if I'm going to, not what I wanted to do there. If I'm going to try to get rid of the x here, so if I look at these, right, there's a 3 here and a 4 here. So I'm going to multiply the top equation by 4. I'm going to multiply the bottom equation by 3. And then again, these are both positive, so I need to make one of these negative so that one will drop out. So I end up with the equations minus 12x minus 8, well, this one's going to work out okay. So minus 12x, I was looking for a problem that didn't work out okay, but I see I messed that up. Actually, I'm going to erase this problem because I copied a piece wrong, and so let's do this again. So let's try the following problem. So let's do 2x plus 2y equals 5, and then 4x plus 4y equals 1. Okay, that's a better problem. Okay, so again, I have to, if I look at these, right, I'm going to multiply the top equation by 4, the bottom equation by 2 to get them to cancel out if I'm going to get rid of the x's. And they're both the same sign. They're both positive, so I need to multiply one of these by a negative, so we'll make it the top one. So if I do this, I end up with negative 8x minus 8y equals negative 20. And on the bottom, I end up with 8x plus 8y equals 2. And if I add these two equations together, so again, just like in my last problem, right, the x's go away and the y's go away. So on the left-hand side, I'm left with 0. But this time on the right-hand side, everything doesn't go away and I'm left with negative 18. So 0 and negative 18, these two things here, these two numbers, they're not the same. And since they're not the same, what that means is that I come down to this inconsistent system. Okay, so inconsistent means like something weird is going on, inconsistent. And because of that, the answer to this problem is actually no solution. So for these weird kind of systems, if you ever get 0 equals 0, right, that is consistent. And it means there's infinitely many solutions. And if you ever get down to a number equals, or I should say, rather than a number, if you ever get down to 0 equals a non-zero number, that means there's no solution. So there's these two kind of funky cases that go on that you just want to be aware of.